So for example number 3, it's not necessarily proven the theorem, but it's basically the same thing as example number 2. It turns out that if I have these inscribed angles that intersect, or I call it a bow tie. In other words, if they share a subtended arc, right? Then the angles, their corresponding inscribed angles are congruent. So if I have E, G, F, H, and I'm told that the measure of angle G, E, H is equal to 75 degrees. Okay, this is 75 degrees. And they want me to find the measure of angle GFH. Well, because G and H is the subtended arc, or the intercepted arc. I probably should have mentioned that at the very beginning, but I can mention it now. GH is the intercepted arc. That means that's where it crosses. In other words, this angle, intercepted arc. If they share an intercepted arc, then their corresponding inscribed angle is congruent. So, in other words, this is equal to the measure of GEH, which is equal to 75 degrees. Now, where that comes from, because they share this intercepted arc, we know that 75 times 2 gives us the measure of GH, which is 150. But this is another central angle of the 150, so to find this angle, it's just going to be divided by 2. So this would be 75 degrees as well. Okay? That's pretty easy.